Okay, we are on 8.8 for algebra. This is the last new lesson in the chapter. So you guys will be getting ready for a test very soon. So the last lesson is 8.8. It is factoring by grouping. So here are the rules, and I'm sorry this is at the very bottom of your paper, but if you look at the very bottom of your paper, this is the summary. So first, you're going to factor out any greatest common factor. So we always want to do that first. If you remember previous lessons, anytime you look at a trinomial or a polynomial of any kind, first thing you want to do is see if there's a greatest common factor that you can pull out. Okay? So let's start there. I'm actually going to rewrite this problem off to the side because I know that the example is done for you and I'm sure they did a great job of it, but I would like to work it out for you on my own. So it is 3n cubed. If you guys would write this out on your paper too, that would be helpful. Minus 12n squared plus 2n and then minus 8. All right, let's take a look at this. Do we have any greatest common factors that we can pull out of all four terms? So we've been doing trinomials a lot. This is bigger than a trinomial. Anything past 3 we just call polynomial. So this is a polynomial with 4 terms. These 3 terms could divide out by 2, but this one can't. And these 3 terms all have an n, but this one doesn't. So here's what happens. If the polynomial has 4 or more terms, group the terms and factors together to find common factors that we can pull out. So it is my habit to go ahead and just put parentheses around the first 2 and around the last 2, but just something that you guys should know, you can move these around. So like if this one had a common factor with this one, we could have grouped those together and these together. So it's just my habit that if these 2 have a common factor and these 2 have a common factor, to just go ahead and put parentheses around the first 2 and the last 2. So let's just look at only this first one. In fact, I don't want you to look at the second one at all. So look at our first binomial. What can we factor out? What is the greatest common factor of 3n cubed and minus 12n squared? So they can both divide evenly by a 3. So I'm going to pull a 3 out front. And they both have how many n's? They both have at least 2. So this one even has 3. So I'm going to pull out 2 of the n's. And now we're going to reverse distribute and see what would still be on the inside. So 3n squared times what would give us 3n cubed? We've already done this lesson before, so this should be pretty easy for you guys to remember. That would just be n, and this would be minus 4 because 3 times negative 4 gives us that negative 12. N squared is already on this one, so we don't need to add it here. So it's just 3n squared times the quantity, n minus 4. Okay, now let's do the same thing, but just with this one. So I want you, that's not going to be big enough to cover it up. Let me put this over it. So I only want you to look at the 2n minus 8. What can we pull out as the greatest common factor of 2n and minus 8? It would be just 2. 2 divides evenly by both. So then let's put our parentheses. We can't pull an n out because there's not an n on the 8. So if you reverse distributed, 2 times what would be 2n? And 2 times what would be 8. Okay, so here's what happens now that you have both greatest common factors pulled out of each group that we decided to group. This is really cool. You know you did it right if this set of parentheses is the same as this set of parentheses. If these 2 binomials are different, you did something wrong. So the answer is one of these, because you don't need to write it twice, just one of these, n minus 4, and whatever is left on the outside, so the 3n squared and the 2, and that's a positive 2, so it's going to go into a set of parentheses, 3n squared and plus 2. And that is it. So what we have done is we have taken a large 4-term trinomial and we've broken it down into 2 sets of binomials, and then we've pulled out the greatest common factor from each one, and if we did it right, the n minus 4 would be written twice, but we only need to write it once in our answer. That's just how we check it to make sure we did it right. And then whatever's on the outsides, the greatest common factors we pulled out, you put in its own set of parentheses. The other way we can check it is now you can box this or foil it. You can check it, and if you box this or foil it, and I'm not going to take time to do that right now, but if you go ahead and do the n minus 4 and the 3n squared plus 2, which is what we got, your final answer is going to be this whole polynomial, which is what we started with. So you guys did that right. All right, let's try several more of these. This is only 1 page today, but it's all just doing the same thing, so we're grouping. Remember, the first thing you do when you group it is you have to look, I'm going to zoom in just a little bit, is you have to look and see if there are any greatest common factors that would be pulled out of all 4 terms first. So if you can do that, you have to. But this one ends in a 5 and these don't, so that's not going to work. Okay, so we're going to have to group this. So I'm going to just put parentheses around my first group of 2 and my second group of 2. So again, don't look at the second group yet. We just want to look at 8t to the third plus 14t squared. So what can you pull out? What is the greatest common factor of 8 and 14? I think it's just 2. And of t to the third and t squared. The most you can pull out is just t squared. All right, and then we're going to reverse distribute this. So 2t squared times 4t would give us that 8t to the third. And then 2t squared times 7 would give us 14t squared because the t squared comes over with that. So that one's done. Okay, now let's just look at our second group, 20t plus 35. What can you pull out as the greatest common factor? I think it's just 5. 5 divides out of both of those. So then let's reverse distribute it. That would be 4t, 5 times 4t is 20t, and then 5 times 7, positive 7, is 35. So let's check to see if our answers are right. The reason you know it's right is if what's inside the parentheses is the same both times. And it is, but you only have to come down here in your answer and write it once, and then you write what's on the outsides, the greatest common factors you pulled out, in its own set of parentheses. That's a positive 5, so plus 5. And that is your answer. Okay, again, you can totally check it by boxing or foiling or whatever you like, and your answer will be back to our original polynomial. Okay, if you want to push pause and do the you try, I think that's a great idea. If not, I will work this one out with you too. All right, first things first, check and see if there's any greatest common factor that will come out of all 4 terms. There's not. So I'm going to group it like this. Be sure you group your negative with the 10q. All right, this one is actually, I don't know if you guys tried this on your own. I kind of hope you didn't, because this one is really important with the first term being negative. I mentioned this in a previous lesson, but it will depend on if you remember what to do with that one. But let's not look at that one yet. So let's start by looking at just the 6q cubed plus 3q squared. We can pull a greatest common factor of 3 and q squared out. And that would leave inside 2q, because 2 and 1 is what's going to give us our 3, and plus just 1, right? Because 3q squared plus 1 is 3q squared. So you do have to put that plus 1 there. You can't just leave nothing. So you have to be able to distribute it to a plus 1. All right, let's check this one. Okay, this is what I was talking about. Anytime your a term, which this is my a term because it's my first term in this binomial, anytime that first term is negative, you have to pull out a negative with whatever common factor you pull out. So if you do not right now divide out the negative, your answer is going to actually be wrong. And you'll know because what we got inside this set of parentheses would be different than what you got inside the other one. And that tells you you're wrong. So you can pull out a negative 5. because 5 itself can come out. So negative 5 times 2q gives us the negative 10q, and negative 5 times positive 1 is what's going to give us that negative 5 up here. So then we go check, and now these two are the same, so we know we did it right. Again, if you did not divide out that negative, it would be wrong, which is why anytime your first term is negative, it has to come out with it. So one of our sets of parentheses is 2q plus 1, and the other set of parentheses is 3q squared minus 5. All right, let's keep going. We have 2 left. So this, oh, you know what? I'm going to actually skip this one. They've worked it out here for, oh, we probably should not skip this one. But that's okay. They've worked it out here for you. This next one is almost exactly like it. So I will show you what happens if you can factor out a greatest common factor from all 4 terms, which is also going to happen here. So let's go ahead and jump down to this one. So remember, I've said the very first step, it even says here at the bottom, the very first thing you need to do is factor out the greatest common factor if there is one. So when you look at these 4 numbers, I hope you right away know that there is something that will come out of all 4 numbers, or all 4 terms, and it is 3. You can't pull a 6 out because that won't come out of a 9. It won't divide evenly out. Sorry, I should be telling you what I mean. So you can divide out a 3. Now, what about h's? You have 4 here, 3 here, 2 here, and you still have 1 here. So we can actually divide 1h out of each of these 2. And it leaves all the things that would be on the inside. So let's go ahead and reverse distribute it. 3h would leave 2h cubed to get 6h to the 4th. 3h times 3h squared would give us 9h cubed. 3h times 4h would give us 12h squared. And then the last one is 3h times 6 would give us 18h. Now, you're still not done because we still have some like terms in these 2 and some like terms in these 2. So I'm going to group my 4 terms into just 2 sets of terms. So I'm not going to forget about the 3h. It's still there. It still needs to be part of my answer. I'm just not going to do anything with it for right now. So I am going to group these and these, and I'm going to now factor out the greatest common factor. So I can pull out of a 2h cubed and 3h squared an h squared. And what it would leave inside would be 2h, because I need there to be 3 of them, plus 3. H squared plus 3, or sorry, times 3 is 3h squared. Okay, we're done with that part of it. Now let's go over here and look at just the 4h plus 6. I can divide evenly out a 2 from these terms. So I'm going to pull out a 2, and it's going to leave inside 2h. 2 times 2h is 4h. 2 times 3 is 6. So here's what I have. The 3h is going to stay there. It's just going to be part of our answer, but we're done messing with it. Does this one match this one? Yes, it does. So that is one part of my answer. And the other part is the greatest common factors that we pulled out of those 2, which would be combined in a binomial h squared plus 2. So that was a big problem. We did it the exact same we've done all the other ones today, but first we pulled out the greatest common factor, and it does come in our answer, but we don't do anything else with it once you factor it out. All right, last one. Look over all 4 terms and see if there are any like terms we can pull out. Actually, we can't on this one. I'm surprised because this one we could. So maybe if you guys want, you should go practice this one on your own just to get another practice of pulling one term out of all 4. But this one, you can't divide by 3 because 2 doesn't divide by 3. And you can't divide by 2 because 3 doesn't divide by 2. So the best we can do is we can factor out, though, a W. So actually, this is still good practice on this one. So we're going to factor out a W. Oops, my pen is running out. I'm going to switch to pink. Okay, so we can factor out a W, and let's see. That would leave us with 3W cubed minus 2W squared plus 18W minus 12, and that's all without a W. Okay, so all I could factor out was 1W. Okay, now we can go ahead and branch this off into this group and this group. So W is still going to be part of my answer, but I'm really not going to worry about it for right now. In fact, I'm going to put it off the camera where you can't even see it. What is the greatest common factor of 3W cubed and minus 2W squared? The only things are 2W's. So W squared is going to be pulled out. All right, that is going to leave on the inside 3W and minus 2. All right, let's look at just the other set. Out of 18W and minus 12, I can pull out a 6. They can both be divided by 6. 6 would leave 3W minus 2. So let's check our answer and see if this one matches this one. It does. Don't forget we've got this W on the outside here. So the W on the outside is just going to stay. But in one set of parentheses, we have the 2 that matched, which is 3W minus 2. And on the other set of parentheses, we have the greatest common factors that we had pulled out of these groups, which is W squared and plus 6. There you go.